Today I am going to explain about Lagrange's method of undetermined multipliers. So what is nothing but Lagrange's method of undetermined multipliers? So this method is useful to find extreme values of a function, subject to the condition involving different variables. So the Lagrange's method is useful to find the extreme values of a function subject to the condition involving different variables. Okay, so now the method of Lagrange's multipliers here method. Let f of x comma y comma z be a function and phi of x comma y comma z be a subject to the condition then put capital F of x comma y comma z is equal to small f of x comma y comma z plus lambda into phi of x comma y comma z. Now this function, this capital F of x comma y comma z is known as here, this function is known as Lagrange's function. So this function capital F of x comma y comma z is known as Lagrange's function, and lambda is known as Lagrange's multiplier. Okay students, lambda is known as Lagrange's multiplier and capital F of x comma y comma z is known as here Lagrange's function. Now next we obtain partial differentiating of capital F with respect to x equating to 0. So capital F contains function and subject to the condition here. So that means dou small f of dou x and plus lambda dou phi by dou x is equal to 0. And similarly dou f by dou y is equal to 0 or dou small f by dou y and plus lambda of dou phi by dou y is equal to 0. The last one, dou f by dou z is equal to 0 or dou f by dou z plus lambda into dou phi by dou z is equal to 0. So this is equation 1 and equation 2 and equation 3. So now solving these three equations, to get the values of x comma y comma z. Okay, at this point at this x comma y comma z point only the function is having a maximum value or minimum value corresponding to the method only here. Okay, so now coming to the problem. So here the problem according to the Lagrange's method. Find maximum value of u is equal to x square y cubed z power 4 if 2x plus 3y plus 4z is equal to a. This is the question. So in the question it was already asked that find maximum value. Okay. So now using this is a function and this one is the subject to the condition. Using function and subject to the condition we have to find out the values of x, y, z. Then at that point the function is having maximum value because the question was asked us to find the value of a maximum here. Okay. Solution. So at first given u is equal to x square y cubed z power 4 and 2x plus 3y plus 4z is equal to a. So let subject to the condition is let subject to the condition is that is 5. Okay. The 5 condition is 2x plus 3y plus 4z and minus a is equal to 0. It is the subject to the condition. And u is a function here and subject to the condition 5 is there here. Then writing Lagrange's function that is capital F of x comma y comma z is equal to capital F of x comma y comma z is equal to the function was given here in terms of u. So writing Lagrange's function in terms of u only. So u of x comma y comma z plus lambda into phi of x comma y comma z. It is the Lagrange's function, students. Okay. So u of x comma y comma z plus lambda of phi of x comma y comma z. Substitute the values. The u function is x square y cube z power 4 and plus lambda into and phi subject to the condition is 2x plus 3y plus 4z minus a. So now the Lagrange's function that is capital F of x comma y comma z. Then after writing Lagrange's function, now doing partial differentiating of Lagrange's function with respect to x and y and z and equating to 0. Okay. Now dou f by dou x. I am writing dou f by dou x, students, and here also I am writing dou by dou x of x square y cubed z power 4 and lambda into dou by dou x of 2x plus 3y and plus 4z minus c. So total partial differentiating I am giving the explanation here. The first thing with respect to x here, dou by dou x of x square y cubed z power 4. So with respect to x here we are doing partial differentiating, then y cubed z power 4 as a common and remaining term dou by dou x of x square, then y cubed z power 4 x square differentiation is 2x. Coming to the second function, that is dou by dou x of 2x plus 3y plus 4z minus c. See here, students, we are doing with respect to x, then 2 common, and for x differentiation 1. There is no x here, that means 3y common, 1 will be there, and for 1, that is 1 is constant, then constant differentiation is 0. So writing 0 here. Coming to this term also, 4z as a common because there is no x there. 4z common, 1 will be there, and 1 is a constant, constant differentiation is 0. Yeah, this value is also 0. Of course, a is already constant. Then finally the answer is 2. Substitute these two values here. Then the first function, first term differentiation is with respect to x here, 2x y cubed z power 4, okay, and plus lambda into 2. This is the value of dou f by dou x. Yeah, according to our condition, Lagrange's multiplier condition. So after finding partial differentiating of the terms here, have to equate to 0 of each partial differentiating individually. Okay. So now and here dou f by dou x is equal to 0. Then that is equating to 0. That condition is here 2x y cubed z power 4 plus 2 lambda is equal to 0. 2x y cubed z power 4 and is equal to minus 2 lambda, and 2 will be cancelled. Then x y cubed z power 4 is equal to minus lambda. This is the value of minus lambda. Okay, so make it at is equation 1. Remember this answer, students. Similarly, if you are doing partial differentiating of f with respect to y here, so I am doing here, observe, dou f by dou y. Yeah, dou by dou y of x square y cubed z power 4 plus lambda into dou by dou y of 2x plus 3y plus 4z minus a. Okay, now I am doing the partial differentiating of this function here. The first function is dou by dou y of x square y cubed z power 4. So here we are doing partial differentiating with respect to y, then x square z power 4 common and dou by dou y of y cubed. Then x square z power 4 and y cube differentiation, partial differentiating is 3y square. And the second term dou by dou y of 2x plus 3y plus 4z minus a. See here, students. With respect to y here we are doing, and the first term there is no y, then 2x is a constant, 1 will be there, 1 is the constant differentiation is 0 only, and substituting 0, and plus 3 y is there, y differentiation is 1, and again here this value is also 0 because there is no y, it is a constant, and again minus 0, and finally answer is 3. You are now substituting the value here. Yeah, substitution, then this value is nothing but 3x square y square z power 4 plus lambda into 3. Okay, then according to our procedure we have to equate this value to 0. Then 3x square y square z power 4 plus 3 lambda is equal to 0. You are now finding again the Lagrange's multiplier value here using this simplification. Yeah, now I am doing that. 3x square y square z power 4 is equal to minus 3 lambda. 3 will be cancelled. X square y square z power 4 is the value of minus lambda. Then it is equation 2. So equation 1 is here x y cubed z power 4 and equation 2 is x square y square z power 4. So the same procedure for partial differentiating with respect to z. Then dou by dou z of x square y cubed z power 4 plus lambda into dou by dou y of 2x plus 3y plus 4z minus a. So here I am doing the partial differentiating of these functions. The first term is dou by dou z of x square y cubed z power 4. So here we are doing with respect to z, students. So which one is the common here? X and y terms are the common here. So what are the x and y terms here? X square y cubed are the x and y term, dou by dou z of z power 4. Then x square y cubed z power 4 differentiation is 4z cubed. second term dou by dou z of 2x plus 3y plus 4z minus a. So here have to write dou by dou z, not dou y. Dou y is completed. Have to do with respect to z here. Yeah, coming here. So see here students, first function there is no z, answer is 0. Second term that is 0, and third term 4, and for z differentiation is 1. So the last a is constant 0, and finally answer is 4. Okay. Now substituting the values here. The first term with respect to z here, the first term is at first I am writing the constant 4 x square y cubed z cubed and plus lambda into 4. Yeah, according to the procedure, again equating to 0, this term 4x square y cubed z cubed plus 4 lambda is equal to 0. Then 4x square y cubed z cubed is equal to minus 4 lambda. Then finally x square y cubed z cubed is equal to minus lambda. So it is equation 3. Okay students. So now using these three equations, getting the values of lambda here, then using 1 and 2. Okay, so what is the equation 1 here? The equation 1 is xy cubed z power 4 is the equation 1 students. Okay, xy cubed z power 4. Yeah, I am writing equation 1 here. xy cubed z power 4 is equal to minus lambda. And equation 2, okay, equation 2 is x square y square z power 4 is minus lambda. Here RHS values are equal. See here, RHS values are equal. Then equating LHS values also. xy cubed z power 4 is equal to x square y square z power 4. Okay, z power 4 will be cancelled, and 1 x will be cancelled, and 1 y will be cancelled. So at finally you will get the value of y is equal to x. So similarly using 2 and 3, so what is the second equation? X square y square z power 4 is equal to minus lambda. And third equation, x square y cubed z cubed is equal to minus lambda. And using these two equations, so RHS parts are equal here, then equating LHS parts. X square y square z power 4 is equal to x square y cubed z cubed. So x square will be cancelled, and 1 y will be cancelled, and 1 z will be cancelled. And finally you will get the answer as z is equal to y. So now observe these two conditions, x is equal to y and y is equal to z. So using these two conditions, so we will write here x is equal to y is equal to z. Okay, it is possible students, right? Of course, because x is equal to y. So how the equation here? See, I am writing. So x is equal to y. Okay, then y is equal to z. Then using these two conditions, we may write down as x is equal to y is equal to z here. So now condition is a, that is x is equal to y is equal to z. Now substituting this condition values in subject to the condition. Okay students, so it was given that in the question, given that subject to the condition is 2x plus 3y plus 4z is equal to a. So substitute x is equal to y, or y is equal to z, or z is equal to x in these values, this subject to the condition. So now I am substituting all values as x here, 3x, and then 4x is equal to a, then 9x is equal to a, x is equal to a by 9. Then according to this condition, if x is equal to y is equal to z, if x value is a by 9, so then that is y value is also a by 9 and z value is also a by 9. So how can you say that three values are a by 9 here? According to the condition, x is equal to y is equal to z only. So now substituting x, y, z values, substituting x, y, z values in u. U function is here x square, y cubed, z power 4. So x means here a by 9 whole square and y means a by 9 whole cubed and z means a by 9 whole power 4. So finally the answer is a by 9 7 plus 2, that is a by 9 whole power 9, adding the power values because bases are equal. This value is the maximum value of the function subject to the condition using Lagrange's method of undetermined multipliers. Thank you students. Please like, share, subscribe Easy BTech channel.